Hi, everyone. This is a lot of people. So, like she said, my name is Kent C. Dodds. I have a talk titled Requisite React, where I'm going to talk about how we can level up our React skills. So this is a whole bunch of stuff about me. On my last slide, I have a link to the repo for this, so you can go look at all these links later. So I'm not going to belabor all this stuff, but I do a lot of stuff that some of you might find interesting. So, as we get started, I don't know about you, but I'm actually still a little bit jet-lagged, and like starting up early in the morning is not always the easiest thing. So I'd like to invite everybody to please stand up. Thank you. If you're physically able, if you're not, do as much as you can. So I want you to put your arms out like this, and squat down and come up. This is called exercise. These are air squats. We're going to do 12 of these. Normally you swing your arms, but I thought that'd be dangerous, so we're just going to leave our arms in front. I want you to count out loud with me. We're going to do this 12 times, and count in your native tongue. Okay, ready? 1, 2, awesome. 3, 4, 5. You're doing so good. 6, 7, 8, 9. Should we start over? 1. No, just kidding. 11 and 12. Awesome. Now stretch up high over your head as high as you can, and then even higher than that. All right, and stretch over to one side and over to the other. Awesome. Now, before you sit down, turn to the person next to you and thank them for coming to the conference. All right. So I do that to kind of make me feel a little bit better, but also our mental health is super important, and you will learn more things because you did that exercise this morning. So you're welcome. And you also get to meet more people, which I think is good. If you haven't already been talking to the people next to you, now you know who they are, and that's good. Okay. I also like to start with expectations because you need to be able to decide whether or not you should be on Twitter the whole time. So hopefully this is helpful. I'm going to be inviting us to take a few steps back and consider the abstractions that we're using and talk about some of the usefulness of learning the fundamentals. But this talk is not going to be about gatekeeping and saying, you should be learning the fundamentals before you can ship anything. You're not a web developer if you don't know how to link to a style sheet or something like that. That's ridiculous. Unless you're building like medical software or airplane software or something, having something shipped is more important than having perfect software because you'll never have perfect software anyway. So this is just an invitation for when you decide it's time for you to level up in your skills. Here are some things that you can do to do that. And a lot of what I'm going to be talking about is abstraction. So I have a little story that's actually a little bit on the embarrassing side for me. So please, I'm being vulnerable here. Be nice. A couple of months ago, my wife and I, our faucet wasn't working. Like there was hard water damage or something, and so we couldn't turn the faucet. We have two sides of our sink. We couldn't turn the faucet to one side, and so we decided to get a new one. And we were like super excited about this new faucet because it just like worked perfect. I mean, as excited as you can be about a faucet. But it worked great. We were really happy with it. And then just like 2 weeks in, this happened where the head of the faucet comes off so you can like direct the water wherever you want it to go. But the head wasn't going back into the neck automatically like it always did. And we were kind of frustrated by that. We just thought it would go away, but a couple days and it still didn't go away, and that was kind of frustrating. So finally, we decided, okay, I mean, this is brand new. They should fix it for free, right? So we called the plumber again and say, hey, could you come and fix this? Like, look at what's going on here. And they said, yeah, sure, we'll be out there in a couple days. The morning of the day they were going to show up, I was looking at this, playing around with it, and I thought, man, like, why is this even happening? How does this even work? So I went down under the sink where the hose goes down, and I looked at that and I saw this. And so there's a weight on the hose, and that weight is what pulls the head back into the neck, And it was all tangled up, and so the weight wasn't pulling on the head. And so here's how I fixed it. Ta-da! Yeah. And so, like, we endured multiple days of this terrible experience, and like, I think probably the thing that frustrates me, among the most things that frustrate me, is when things don't work the way that they're supposed to, like the technology in particular, but like stuff like this, it's just so much frustration. So much anxiety and frustration and anger was directed at this little problem. I was so glad that I figured this out before the plumber got there. My goodness. Can you imagine the look on his face when he's like, okay, yeah, that'll be $50. Like, yeah. So here's the universal truth that I want to communicate to you. The better you understand an abstraction, the more effective you will be at using that abstraction. And this faucet head, like that is an abstraction. It's an abstraction that allows me to use the water that comes through the hose a little bit easier. Like I could use the hose directly, just like pull it out from under the sink and pour it into my sink. But we built this abstraction, this faucet, to make it much easier to use that hose. And we build abstractions like this all the time. Your phone is an abstraction, your car is an abstraction, and the better that you understand these things, the better you're able to use them. And that's not to say that you can't use these things without understanding the abstraction. Absolutely not. You can, like, I was able to use that faucet for a long time without understanding how it worked. I can use cars, and I have no idea how cars work. And my phone and all of those things. You can use React, you can use JavaScript without really understanding how it works, and that's totally cool. And people ship amazing things without really having a deep understanding of how it works. But if you really want to level up on your ability and speed and skills there, then understanding how it works is the way to do it. And taking a little bit of time with those fundamentals really helps you get there. So to look at a code example, there's a site, youmightnotneedjquery.com, which is kind of fun. And on there, they show you a list of jQuery methods and then their associated JavaScript function that you could write instead, and you just drop all jQuery. So let's pretend for a moment that you are in a code base and you are using this, select this element, toggle this class name, and you said, that's the only time we're using jQuery in this project. Let's get rid of jQuery. We'll pull in this function from youmightnotneedjQuery.com. And here we'll take, if the l.classlist is available, I guess there's a toggle on there, but for browsers that don't support that, then we have to do all this stuff. And so you're writing tests, and you're like spending a bunch of time to simulate this kind of environment where classlist isn't supported, and you're doing all this stuff. And then a couple months later, you are reading on MDM or something, and you realize, oh wait, classlist is supported by every browser, IE 9 and up. So all that work that I did to make sure that this code never breaks and that it is well tested was like totally worthless because we don't support IE 8. I was going to ask if people support IE 8, but I just know that I feel bad for you. And keep working, fighting the good fight, and help people upgrade from unstable browsers. So this is an abstraction, and really, when we understand our abstractions a little bit better, the lower level abstraction of the DOM, we realize that actually we don't need to write all of this code, and this function can just be this. And then you think, well, actually, I don't even need that function anymore. I'll just call the toggle method right on the class list, and that's not a big deal. And so by understanding the abstraction that we're using, the DOM in this case, we're able to significantly simplify our code and also give our end users a better experience, not shipping so much code to the browser. So here's another universal truth. Every abstraction has a cost. No matter what the abstraction is, every single one has a cost. So what I want to encourage us to do is to be mindful of our abstractions. And as you're thinking about your abstractions, ask yourself, is the benefit of this abstraction worth the cost of the abstraction? And be mindful of what the cost is. Now, the benefit could be, I realize that this cost, it's a huge cost, but I need to ship this thing, immediately, so I'm going to eat that cost for the benefit of shipping today. And then we can iterate to a better solution tomorrow. But being mindful of these abstractions is really helpful. So we're shipping apps. We're really happy with it. We want to level up. What do we do? How do we do that? I want to talk specifically about some React abstractions that we really like. And hopefully this, like, maybe you'll learn something about these abstractions in particular from my examples. But I'm actually more interested in showing you kind of a process for diving into abstractions. So the first one that I think we kind of glaze over when we're learning React is JSX. And understanding what JSX actually represents when it's compiled by Babel. So I have some examples here to just show that to you a little bit. The way that you can learn this abstraction is you can go to the Babel REPL online, and you just put in your JSX, and you see what comes out of that. And just that process can teach you a lot about JSX and can make you more effective at using JSX, because when you understand it, you can use it better. So here we have a div with an ID of root and hello world. That compiles to react.createElement with a string for the element name and an object for the props, and then a string for the children. And so the React createElement API accepts the element type, and that can be a string, or it can be a function, or it can be a class, which is a function. But, and then we also have the props object, and then for all of the children, they just wind up as the rest of the arguments to createElement. And that like in the process, we can learn like several things about how JSX and createElement work, and it helps us to translate our JSX to just regular JavaScript. This is why React developers often like to say, well, it's just JavaScript. Well, yeah, I mean, it's JSX, but when it's compiled, it is just JavaScript. And so when you understand that, then it helps you use the abstraction more effectively. So if you've never console logged JSX before, I encourage you to do it, because lots of times we look at this JSX and we think this is just some magical thing that happens, and then Babel does some magical thing, and then React does some magical thing, and then my div appears on the page. But the magic is all just JavaScript. It's written in the same language that you write in every day. And when you console log a React createElement call, what it gives back is, or what it'll print out, is this object. It's called a UI Descriptor Object. And it's just an object that describes the UI that you want to have rendered at that spot in the tree. So it defines the type and the props here. Then there are a couple other things that are like, I don't even know what those things are. I need to dig further, I guess. But here, what's interesting when you do this is you see that even though children was not part of this props object, when you do React createElement, it actually adds children to the props object, which is interesting because then we can actually write this same thing in 4 different ways. And understanding that can help you understand why when you make a component and you want to render children, that children is coming from props. And then that children, it's whatever you want it to be. It can be a string, or it can be another React element, or it could be a function for render props, for example. And then children can be an array. And this is actually not how Babel compiles that. Babel will compile it as multiple element or multiple arguments to the React createElement function. Interpolation, this is, I think, a really important thing to grasp about JSX is how interpolation works. And so when you do this open curly brace, it basically just says, hey, React, or hey, Babel, I don't want you to touch this thing. I want you to take whatever is between these curly braces and just stick it in as an argument to the createElement function. And so when you understand that what you put between these curly braces is just an argument to a function, then it makes a lot more sense why you can't do something like if foo, then, I don't know, var, or whatever, right? It makes sense because you couldn't do something like that in an argument list, okay? So understanding that piece of the abstraction really helped me use React more effectively and be able to intuit what's going on under the covers. Spaces are just another argument to the function, which is why sometimes you wind up with an extra space, or maybe you're missing a space. And then our interpolation on attributes works exactly the same. It says, hey, Babel, just take this expression, whatever that is, and stick it as the property of this object that we stick into props. And render props work this exact same way. So here we have a render function, and we just stick it in the children position, and then downshift consumes that and calls your children function. And while we're talking about downshift, this is called a custom component, and then this would be a composite component. And so custom components are just references to variables, whereas composite components are strings. And this is just kind of a fun little exercise to play around with the Babel REPL and see, okay, how does it determine whether it should be a variable or a string? And so if it's capitalized or has property access, whether that's capitalized or not, then those are going to be our custom components. If you try to do a bracket, by the way, that's a syntax error. I'm glad of that, because that looks kind of weird. Yeah, then lowercase, it's going to be a string. The React team, I saw somebody, I think it was Sebastian, once tweeted, I still can't believe we got away with this. Makes sense to me. And you have kebab case, whether it's upper or lowercase, is going to be a string, and that makes sense, right? Because that couldn't really possibly be a variable. That would be upper minus kebab minus case, right? So that wouldn't make sense. And then when you do upper snake case, that's a variable, and lower snake case is going to be a composite component. So then we have our more interpolations, and I like this example because it shows us that, yes, we have a ternary here, but that just winds up getting placed as part of the argument to our createElement function, which, again, is just a really helpful thing to internalize about how JSX is compiled. And then here, just in my last couple examples, when you do items.map, you're literally taking an array of one thing and mapping it to React elements. And so this is just a React createElement call for each one of those things. And what winds up getting passed as this second or this third argument to the createElement API is an array of other React elements. And so that's why you need a key in place, because React can't keep track of the order of those things. If you remove one in the middle, then did you remove that one, or did you actually just like change the attributes to that particular one? And so that's why you need to pass a key. And then for my last example, spreading props is just using object spread. So here we have some props that we've specified. We have some props that we're spreading, and then some more props that we specify. And that ends up looking pretty much just like this. And so that's why the order of these things matters, because if I were to change this and put it here, then that essentially just moves the order there. And so if you understand how this is going to be compiled, you can use this particular abstraction better. So the next thing I want to talk about really briefly is hooks, because we're all like super excited about hooks. Sean Wang, my buddy, who is just an amazing person, he just spoke at Reactathon recently and gave a talk about this, and he has a blog post where he shows you how to build kind of his own custom implementation of hooks, and it is really instructive. And so I'm not going to dive too deep into this particular example. I mostly want to show you that trying to build something yourself is a really great way to get a solid understanding of that particular abstraction. When I was just starting in coding, one of my coworkers, Merrick Christensen, really awesome person, he said, I said, okay, so how do I learn JavaScript better? And he said, try building underscore. This was before Lodash, so. But he said, just look at your underscore methods and try to implement those methods. And I mean, I never actually did it, so I guess I'm not as good of a JavaScript developer as I could be. But I think that's great advice if you want to level up your JavaScript skills. So feel free. You can do underscore or Lodash, whatever you want to do there. But so Sean kind of built his own implementation of hooks. So we'll just look at this really quickly. React keeps track of your hooks in an array. Oh, by the way, this is not how hooks is implemented. Like, it's quite a bit more complex than this. But this is like conceptually how hooks work. React keeps track of your hooks for a particular component in an array. And every time you call a hook, it's going to put some information in that array. And it keeps track of the current hook that's being called. So whether you're calling use effect or use state or use layout effect or use context, each one of those is associated to a particular index in that hook array. So every time it renders, it knows which hook you're calling at this point in time. And so here, before it renders, it sets the current hook to 0, and then it calls the components render method. And here for use effect, he's just saying, hey, here's my dependencies for my current hook. And then for the use state, he's saying, here's my value, my state for the hook at this current index. And then here's an updater function that will update the set state hook index to whatever new state is provided. So trying to write your own version of these abstractions is a fantastic way to dive deeper into the abstraction. Another great way is to look at the source code. And so with React Suspense, we're all like super, so I love hooks, but boy, am I ready for Suspense. Like, this is going to be a killer feature, and I wish that it was out right now, like really bad, but who knows? It may never come out even this year. I don't know. Eventually it will come out, and I will love it. But React Suspense for lazy loading, or code splitting, is actually available, and you can use that today. And so I was looking around in the code for react.lazy, and during the render method, when it's trying to render a React lazy component, this is some of the code that is run. So React lazy accepts a function that returns a promise, just a dynamic import statement. And that promise, when that is in a resolve state, then we know what the component should be because it maintains that state. If it's in a pending state, though, then it actually throws the promise. This is happening during render, so it'll throw the promise, and then presumably our suspense thing is going to catch that thrown promise, and then it will be responsible for re-rendering when that promise resolves. So, first off, huge warning, this is not something you should do. Don't do this today. It is very likely to change, but I'm going to show you how, and actually this repo that you can look at, this actually does work today, but I'm going to show you how you could use the current iteration of Suspense to load data. Again, don't do this. If the React team wanted us to do this, then they would have said do this, but they don't. In fact, Dan tells me not to do this. He might get mad at me for sharing this with you, so maybe don't tell him. Okay, so with that disclaimer out of the way, the current iteration of React Cache actually doesn't work with the current version of React. It's going to wildly change, but right now the way that it works is you have some sort of resource thing, you call read on it, and you pass any arguments that you want. And so because that doesn't exist yet, we need to get this Pokemon information for this Pokemon name somehow, and we have an API that we can call, and that works great. How are we going to get this Pokemon information? Well, we need to get a promise if we're thinking about the React lazy, so we're going to get our promise, and that's going to be, we'll just grab that and stick it here, and we'll make that dynamic Pokemon name, and that's going to be our Pokemon data. Okay? So we have our promise. I mean, we couldn't set the Pokemon right here because this closure is old or whatever, so let's figure out what to do with that later. And then we're going to throw the promise. Okay. But eventually we do want this to resolve, and we want it to set some state and some data or something and have it re-render, right? And of course, we are going to need to wrap this in Suspense, so let's do that really quick. React.suspense, and we'll need a fallback. We'll just do ... because we don't really care. And so that Suspense is going to catch the thrown promise, but when that promise resolves, it's going to re-render. So we don't want to just have it keep on throwing that promise over and over again. We need to have some sort of, like, only throw the promise if we don't have the Pokemon. Okay, well, let's just add a little cache here. Except we need to spell cache correctly, otherwise it won't work. No, just kidding. We'll have a cache here, and we'll get the Pokemon from the cache by the Pokemon name. And if there's not a Pokemon in the cache, then we can do this stuff. And then we'll just, when we get that Pokemon data, we'll say cache at the Pokemon name is that Pokemon data. Okay, and that'll work. That actually does work. You can look at this later, pull it down, run it. It legit works, and it's pretty cool. So if we follow through the code, we're going through here. There's no Pokemon in the cache, so we're going to go fetch that Pokemon. We'll set it into the cache when that resolves, but we're going to throw this promise. Suspense will catch it. It will say, OK, promise, when you're all done, then I'll try to re-render again. And the second time we come around, now we do have a Pokemon in the cache, and we render out that Pokemon. Please don't write code like this. Nobody wants to read throws in your render method. But the abstractions that are built on top of at least the current iteration of Suspense are going to work something like this. Now, Suspense could change its implementation. That's fine. But diving into the code to understand how your abstraction works is an awesome way to understand your abstraction. So just in closing, I want to say, how do you level up? I think it's really awesome to learn the fundamentals as you're trying to level up. Learn how your abstractions work, and don't be afraid of node modules. It's not as scary as you think it is. So feel free to dive in there. And maybe even better, go to the GitHub repo, because everybody's compiling their stuff now, and your node modules looks kind of ugly. But yeah, you can learn a lot by diving into your node modules. So I have some resources for you. You can, like I said, my link to the repo is on this last slide, so you can take a look at that. And also, that's my font and theme, so please don't ask. And here's why I'm using an editor for my slides, so you can check that out later. Thank you very much.